What's up, bosses? I'm JoeMan543. Welcome to the stream tonight. It's math time again. I didn't think I'd be doing this. I'll explain that in a minute, but it's just math right here. You know, kind of got a book full of it. Well, actually, we're only like halfway into this thing, maybe a third. Yeah, we got a lot of room left for doing math. Yeah. So I am a college student, and I'm getting ready for some fall classes. And so the purpose of doing the math, I'm turn the music down. I feel like it's just a little too loud still. Yeah. So the purpose of doing the math is that I could start from the bottom, work my way through a number of classes, and ultimately I need to pass physics. Physics requires calculus. Calculus requires pre-calculus, and it goes on. In high school, I passed pre-calculus. Yeah, that was a long time ago, but I passed pre-calculus, so I'm hoping to test high enough, take pre-calculus again, and then take calculus and physics. So that's 3 classes instead of... I think I skipped 3 classes in total by doing that instead of starting from the bottom. So half the time. But I need to do studying and prepare for the test. So with that, I'd like to welcome everyone that is here right at the start of the stream. Welcome, Jacob Robert Castro. No, just Jacob Castro. When did you change your name? Welcome, Jacob Castro. Math time. Here we go. Noobified DGC Pictures Entertainment. Math Joe Man. Devlin H5 Arbiter. Probably Halo 5 Arbiter. Trickish Spark. Pimp Daddy. And I think that is everyone so far. Welcome. Welcome to the stream tonight. This sounds like something that Dr. Teeth and the Electric Mayhem would make. Dr. Teeth. Is Dr. Teeth related to the Tooth Fairy? like if the Tooth Fairy is, you know, like a fairy, Dr. Teeth would be the evil scientist of that universe. Trying to steal all the teeth in some evil way. Yep. So yeah. Gonna do some math tonight. Now, I will also do some math outside of what we normally do because I need to also do some studying in that regard. Let me get into a thing right here. And yeah, so as far as the testing situation goes, so I did stream last Wednesday, and then Sunday, so after that stream a few days ago, Sunday, I did take a test, but it was just at home. It was not proctored. It was not an official test, so it didn't count. Let me pull something up on my screen and I can share here. All right. So this pie right here is like the things I've learned, right? And up next we have a knowledge check. I just took a test. Why are we doing a knowledge check? Okay. Anyway, so looking for, I think this is what I'm looking for. Okay, yeah. So when I first took it, way back in January, I scored a 41. 41 is not good enough. Let me see if I can bring something else over. Okay. Yeah, I'm gonna switch back to this. I want to be careful about what I show. Let's see, we're gonna... I'm being careful about what I show. Okay, well, I guess you're gonna get to see some of my desktop while we are at it. Is that everything? Okay. Okay, so back to this. Yeah, just gotten some things off. Anyway, so Alex is the thing I'm doing. So that score, 41. If we go based on here, because that score is in the Alex system, score 41 puts me down here in Math 1010, which, you know, remember when I talked about starting from the bottom? I skipped like 1 class, but let's be honest, that doesn't really get me very far. What I want to do, though, is score up into this range up here, so that I can hop into Math 1080. Math 1080 is the pre-calculus, so I mean, even higher would be awesome, but I want to keep some realistic goals. Yeah, so improving my 41 up to over 55. That is the goal. I've actually already taken Math 1040, but that was so long ago, it actually kind of it didn't expire. The class still counts, but like 1040 doesn't contribute to 1080. Anyway, so this 56 here, it was an unproctored test. So even though 56 is high enough to get to this range, it was not official because it was not proctored. So that is why that is the way that it is. And so we need to do a little more studying. And tomorrow I will do a real test at the testing center. So yeah. Oh, Insane Gamer, welcome to the stream. Falcon SRT as well, welcome. Vampire Queen, Queen of all vampires, hi. Welcome, welcome. Back to math. You need more views, bruh. We all learned something. Hey, it's interesting how these math streams get maybe half as many views, maybe a little bit more, than my Friday streams where I actually try to be entertaining. So either I'm good at being entertaining on math, or I'm really bad at it on Fridays. I don't know. Anyway, yeah, I expected more from your desktop wallpaper. I'm pretty basic. Yeah. Gamerbread, welcome to stream. Wart. All right, so I think let's get into it, do some testing, and I know especially that I need to do some review with some trigonometry. Bishop M, welcome to stream. More math streams. I feel happy someone is doing this. Thank you, Bishop. So the first thing I'd like to do is review some notes from my unproctored test. Unproctored, unofficial. I don't feel too bad about reviewing notes from it. So I think first let's do that. So I need to arrange this. Well, actually, no, I don't. Yeah, I don't need to arrange this because it's just going to be the camera. You don't need to see my screen. So I could put this out here. And then watch this magic right here. Boom. All right. And we can actually like kind of zoom in a little bit. Okay. So from the test that I took, let me get to the beginning of that. Okay. And I'm going to blow my nose real quick because noses be like that sometimes. I know the trumpet noise, it's kind of funny, but it does work. Kenny's Day 543. I love the numbers in your name. Welcome to stream. Do that homeworks. Oh yeah. Caden Hills, welcome to stream. Yep. So I remember math. Those were the days. Yep. How do I get the campaign and multiplayer cursed Halo? Oh. You literally just replace the map files on your computer. That is literally the only step. You go download the mod, which means you download the map files. You go find the map files on your computer. You replace them. All right, back to math. So, on the test that I was taking, so I just wrote down some formulas off the top of my head that I thought I might need, and I should do I should spend some time memorizing more formulas. So area of a circle, pi r squared. Circumference of a circle is 2 pi r, and surface area of a cylinder, 2 pi r squared. No, pi r squared plus pi r squared plus 2 pi rh. Anyway, so I should add to this, and I will tonight with some sine, cosine, tangent, and logarithm stuff because that appeared on the test. I need to know it. So. Anyway, so the first thing that I encountered on the test, obviously I can't show the problem. These were just notes I took while I was doing it, but it was just finding the area of a thing. So, you know, I plugged in the radius, boom, had some area. And the circumference, see, I plugged it into 2 pi r. I got the circumference of that as well. That was easy enough. Very much in the comfort range. And then it threw a problem at me that problem, and it's like, hey, simplify this thing. Oh, and to be clear, the test did not tell me if I got it right. It just sort of moved on and either got harder or easier, you know. So I do not know if these were right. I know some of them were wrong, though. Anyway, so I simplified that, and then I'm like, you know, I started doing this thing, and then that wasn't right. Anyway, so I figured I could multiply this by that, and that's about as simplified as I could make it. Like, I could pull that out of it. Here's a good one. I'm going to skip down a little bit. Is the light making hard to see this? I don't know. Anyway, 27 to the 4/3 power. I did recognize that one as 27 to the 4th power within a cube root. So I just broke that down, and 81 popped out because 3 popped out of that, 3 times 27. So that was pretty simple. 3 times 5 squared plus 1. Oh. I think this was just a simplification thing. I don't know. Yeah, without the actual problem, I guess this probably isn't all that helpful. All right, I guess what I'm looking for here is areas that I need to improve on. Things that maybe now I recognize as not correct. Okay, this right here, this was, I think, the first time that I encountered a triangle, and I had to do some trigonometry. It's a hard word, trigonometry. So I think I was asking for an angle. Let's see. So I'm pretty sure I got this one wrong. So I need to... Actually, no, I think I got this one right, but that's because I got to it a wrong way. I didn't use sine, cosine, anything like that. I just sort of did a ratio of like this side is that big, other side that big. Anyway, so I definitely need to spend some time learning sine, cosine, tangent, because that's going to appear for sure. All right, and then this one was like a parallel line and a, what do you call it? What's the line that's like exactly not parallel? Well, obviously I need to learn that. Anyway, so I was just figuring out the slopes, rise over run, simple as that. I did graph it out just to like get a visual representation. Pretty simple. Neto Shayla, welcome to the stream. I'm gonna flip this over. I'm trying not to like hit my microphone because it is kind of down on my desk. So, all right, here. What was I doing here? 3x squared. Okay, I left some space because I think I was gonna try a few routes. I think I broke this one down. How did I break this one down? I definitely need some practice in this area as well. Just breaking down these complex things. Yeah. All right, and then moving on. All right, this was a fun one, and I'm pretty sure I got this one right. It was like, find the area of the shaded area. So then, like, I figured out the area of the rectangle, 12 times 6, and then the area of the circle, pi r squared. But then, you know, it was only half circle, so divided by 2. And so then I had my circle area, 12 times 6, I had my rectangle area, minus the circle out of it, and then I got the shaded area. So simple as that. Yeah, angle, perpendicular, that is it. Thank you, Reynard. Yeah, on that last one where I graphed it, I needed to figure out perpendicular. Okay, and then this one, 18 u to the 12. So square rooting a power is basically divided by 2, because u to the 6th and u to the 6th, you can pull that out. So I feel confident about that one. Let's see. Okay, this next page, this is where things got a little crazy. So, yeah. So we had some V's here, and it's like, hey, factor this out or something. So I did, and that's what it came out to. And then this was just my checking, like, does it, you know, turn back into that? And so then I factored it out, and then, yeah. And looking at this problem is like simplify all this. I could get some practice in that area for sure. Okay, and then the last page here. This is when they were going hard on the like trigonometry. So I was given a triangle, but it was not a right triangle. That was part of the problem. So I was given some angles. I don't remember which ones I was given. I know I wasn't given all of them. I think I was just given 46 degrees, and I figured out the rest maybe. And I'm pretty sure I got this one wrong. But anyway, it gave me like 3 pieces, and it's like figure out the rest of the pieces. So it gave me half a triangle, want me to figure out the rest of it. I think I had 2 sides, so it was really easy to figure out the others. No, or was it? Yeah, I think. Anyway, I need to do some practice with sine, cosine, tangent. So, you didn't put the units on the result. My teacher always subtracts points for not using units. Yeah, and when I'm writing it, I definitely don't put units. Anyway. Oh yeah, I should probably like focus my camera. Probably why it doesn't look good. I got focused. Oh, well, there we go. It's focused now. Yeah, before it was like blurry. Alright, so things we need to learn tonight. We need to learn sine, cosine, we need to learn tangent, and I'm gonna sneeze real quick. Man, allergies are something, I don't know. Alright, and I want to learn about logarithms, because I know that's going to be a thing. Just tossing that in there, because I think that's, because they do that. What else? Sine, cosine, tangent, logarithms. We did a lot with circles. I feel pretty confident about that one. Yeah, and just like factoring. I don't know why I put a C there. Factoring. So that I think are the top 3 things for me to learn tonight. So let's get into it. I'm going to start with some regular study. So let me get my screen in order here a little bit. Oops. Make sure I span this all the way out. All right. And then we're gonna bring this in. Make it big. Perfect. Okay, let's do some math. It's only taken 20 minutes. Alright, so we got our pi. Start knowledge check. I don't want a test to be followed up by a test, and then another test tomorrow. Last triangle is not a right triangle. Sine, cosine, tangent only work on those, if I remember correctly. You might be right, Reynard. Yeah. Alright, let's see. Well, we need to put an hour and a half into our learning, at least. My nose just hates me tonight, I swear. Okay. So, there's a knowledge check here. I guess we're gonna do it. I don't really want to. Not that I have much choice, though. Alright, so, I'm gonna bring this over a little bit here. The stream just might be a knowledge check. I'm gonna turn the music down just a little bit. Okay. So, I guess we're gonna do the knowledge check. I'm not looking forward to this. Because I swear we just did a test. Alright, so there's probably gonna be 20 questions. Let's bust through this here. So, solve for V. I guess since we're trying to figure out what we need to work on, an knowledge check would be a good thing. So, oh well. My microphone is in the way of looking at my paper, so it is a little awkward to write around this. That's the sacrifice for good audio quality. I have an idea. Aha! I'll just use that space there. Aha, I'm smart. Okay. That was way better. Until I have to put my bottle on this, then I don't know. Yeah, let's solve for V. So absolute valueify this. So then minus 10 from that, negative 5. Divide by 5. So V is going to equal negative. What am I doing, man? Alright, V is negative 1. And then here's the thing, V could be negative 1 or positive 1, right? So let's plug this in. So if we have negative 1 here, that's going to be negative 5 plus 10. Negative 5 plus 10. So we're going to be left with 5. 5 equals 5. But, okay, maybe this is just a single value. If we plug just regular 1 into this, 5, 1, so 5, so 15 equals 5. That doesn't work. So V equals negative 1. It's got to be the right answer. V equals negative 1 seems to be the only thing that works with that. So plus 1 and minus 1. Absolute values ignore the symbol. Ah, yes. But if we did, like I just talked about, I think plus 1 would break this, because that'd be a positive 5 plus 10, 15 equals 5. So plus 1 would not work. I wonder, Joe, if you enjoy doing math, I assume, what other subjects are you interested in? I took astronomy. That was really cool. So, okay. Yeah, negative 1 there, so we're going to submit that. And yeah, it doesn't tell me if I got it right. It just sort of continues onward. So, alright, well, continuing here. 1 over 81 to the power of negative 3/4. My notes definitely covered this. There's a second problem there. I'm just gonna skip, or I'm just gonna wait on that one. Yeah, so negative 3/4. So this does a few things. For one, the negative is gonna flip this, and I think that's the first thing that's gonna apply here. So really, I don't know why I'm writing my numbers weird tonight. Wait, hold on. No, that's still 3/4. What am I doing? What am I doing? 81 to the 3/4 power. All right. So then, so really it's 81 to the 3rd power in a 4th root. So 4th root, 81 to the 3rd power. All right, and then I'm used to having my notebook over here, but now I don't know what I'm doing. Natosh Halo, you're doing math. Yes, I am. Okay, so what's the easiest way to break this out? Because I could cube 81 and get a ginormous number. What's the easiest way to go about this? Because 81 breaks into 9 and 9. Would that just be 9 to the 4th power? I think it's 9 to the 4th power, and I just pull 9 out of this, but I feel like I need to confirm with the calculator. I'm just gonna do a little confirm. So 81 times 81 times 81. That's a ginormous number. divide by 9, divide by 9, divide by 9. No, that's not the way to do that. So 81 times 81 times 81 to the... Where is it on this calculator? Ah, there it is. Second that. Okay. To the fourth root, which is 27. Okay, so I would pull 3 and 27 out of it. I could pull 3 and 27. No, but 27. So I know 27 is the answer out of this. I just gotta figure this one out. All right, so 81 to the third power is that big old number, and then to the fourth root is 27. But why? I need a shortcut that doesn't use a calculator. That's what I need right now. Let's see. So it came down to 27. What's the shortcut here, though? Well, how about this? 81, that's 9 times 9. And then we're going to get that several times. 81, and then squared, cubed. Okay. So then to the fourth power. Okay, I know how this breaks down. So to the fourth power. So we're going to pull 4 9s out of it. And then these 9s don't pull out. But we can pull some 3s out of it. So then we have 4 3s. 4 3s times 4 9s. That's how we get 27. Okay. That is the shortcut I was looking for. So, okay, that works. That makes sense. So this one is 27. All right, next problem. Yeah. Knowing the answer is not enough. I need to know how I get to the answer. And I'm going to change the camera up again, just a little bit. Let me bring this back towards there, and then there we go. Put that right about there, so I can get the bottom of my page. Okay. So yeah, we confirmed that last one with the calculator. It was just a matter of figuring it out real world. Let's see. So my phone notified me. Oh, just people liking Facebook comments. Nothing important. All right. One thing about this pen that I like is there's a lot of ink. Like the ink runs very well. One thing I don't like is there's a lot of ink. So sometimes if you just let it sit, you get a big old glob of ink. Okay, so the next one was 32 to the negative 4/5 power. Okay, so that negative is going to flip things. And then it's to the 4/5 power, which is going to be a similar situation as our last problem here. How do we do square root of fractions? Because the negative is going to make it 1/32 to the 4/5 power, right? Blow my nose again. This is ridiculous, man. Go away. Maybe it's I'm leaning forward so much. You know? I don't know. Okay, so yeah, I think we can do the same thing. It's just gonna be 1 over whatever it comes out to be. So 4/5. So going to be the fifth root. And it's going to be 1 over 32 to the 4th inside that root. I could probably expand this a bit too. There we go. Okay. Always fiddling with the camera. So 1/32 to the 4th power. That's gonna give a tiny number. Let's see. So 30. Okay, so let's think about what we did up here, right? So 32, that breaks out to 4 and 8. 4 and 8, and that breaks out to 4 and 2. So if we have 32 4 times, we're going to have 4 and 8, and 4 and 8, 4 and 8, and 4 and 8. That's how it's going to break out for 32 to the 4th power. Now, how many 4s do we have there? We have 4 4s and 4 8s. Now these 8s break out to 4 and 2, and 4 and 2, 4 and 2, 4 and 2. Oops. Just come from the 8. All right, yeah. So we have 4 and 2 broken out there. So then we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 4s. And 4 can break out to 2 as well. So 2, 4, 6, 8, 10, 12, 14, 16, 17, 18, 19, 20. We have 20 2s. So to the 5th. So I'm not gonna do 2 that many times, but it's basically 2 to the 20th power. And then, basically that 20 is going to divide by 4. So 2 to the 4th power, 2 times 2 times 2 times 2. Let's see, that's 2, 4, 8, 16. So we're going to pull 16 out of this whole thing. I think. So, is that 1 over 16? Reynard says 1 over 16. Okay, so I think that might be how we come out of this. So 1 over 16 is how we come out. Let me double check that, because that was quite an adventure right there. All right, so I feel confident about pulling the 22s out of this whole thing. Then divides the exponent by 5. Yeah, I mean, I think that's it. Okay, so 1 over 16 is our answer. That took forever, by the way. So long. All right, let's move on to a new page here. Okay, so simplify the expression. Fun. Okay, so we have a to the 5th times c, but that c is to the negative 1/2 power. Okay, this is going to be fun. And then we have all that to the 5/3 power. Oh my goodness. I hear that drinking pickle juice helps improve your math skills. Joke's on you, albino buffalo. Pickle juice is empty. On a past stream, someone donated $30 to have me drink pickle juice. I don't have any more pickle juice. Ankry, welcome to the stream. Been a while since I joined one of these streams, and it's freaking maths. Yeah, it's maths, plural. No, that's weird. It's just math, singular. Okay, so this is gonna go weird. Trying to think what our first step is here. So c to the 1/2. So ultimately, all this needs to have this 5/3 applied to it because, you know, PEMDAS, friggin' Aunt Sally. Pickle juice is good for cramps, I've heard. Good for causing them, or okay. So if I apply it to that, is that 25/3 or just 10/3? You also did 90 push-ups. I did 75 push-ups Albino Buffalo. Or maybe I did 80. I didn't do 90 though, not quite. That did kind of kill me. It's pro because it multiplies in my nightmare. Yes, the math multiplies. So many maths. Okay. So I'm gonna multiply this in. I think that is how this goes with the parentheses. So a to the 25/3 times c to the negative 5/6. Okay, so then we got to break this down. So a to the 25th in a cube root times c, actually times 1/c to the 5th in a 6th root. Okay, well, a can break out here. I think c is just stuck in there though. Yeah, see, it's not big enough to break out, so I think that is stuck there. All right, and then a over here. So that 25 divided by 3. Well, okay, it's not divided by 3. It's, how should I say it? A to the 24th, we could pull that out 8 times. So a to the 8th cube root of a times the 6th root of 1/c to the 5th. That's crazy. Yeah, let's see. Yeah, I don't know about this one. Assume all variables are positive real numbers. All right, cool. I wonder something. Right now, these can't go together because one is third and one is fifths, or no, thirds and sixths. Third roots and 6th roots. So, yeah. Don't worry, Joe. I'll send you a barrel of pickle juice. I don't know your address, so I'll just send it to Joe Man, somewhere in Utah. All right. Reliving cramps. Relieving. I know you meant relieving cramps, but you wrote reliving cramps, which is just more hilarious. Pickle juice is great for reliving cramps. Okay. So I feel like this is not simplified enough. If I square all of this, it's kind of the same, right? So a squared in a 6th root. Could I do this? Well, not capital. Could I do a to the 8th 6th root of a squared 1/c to the 5th? Can I do that? Bab9805, welcome to stream. Hello, the other 9 people. Hello, Bab. Yeah. I am unsure about this. But I think I can do that. I think I can do that. We're going to find out. A to the 8th. Oh, God. Is that Alex? Yes. Yes, it's Alex. Wait a second. This doesn't even have square roots. Okay, so I have to write it without the square roots. Crap. Okay. Okay, fine. So I think, forget all this square root stuff. I think just up here, forget a to the 8th. It's a to the 25 thirds, which is a wonderful fraction. Just kidding, it's not. Let's see, times, let's see, a to that, c to the, actually it'd be 1 over c. No, I don't want all of it over. What am I doing? Because c would turn into 1 over c, because that negative exponent there. But I can't answer with a square root. I can use exponents or fractions. But write your answer without using negative exponents. A to the 5th times c, negative 1/2. 5/6. What am I might hit, I don't know. I might do it. I might not know how to answer this one. A to the 5th. 25 thirds. 1 over c, but... well, I guess it's times 1 over c, right? Okay, so I can just make this whole thing over c. Okay, so c to the 5/6. I think that's it. This is not a pretty answer, but I think this is it. Okay, we're submitting that. And we're only 4 questions in. Oh boy. Okay. Suppose that the functions r and s are defined for all real numbers as x, all real numbers x as follows. rs. So write the expression for r minus s of x and r times s of x, and evaluate r plus s 2. Okay, so what am I doing? So r minus s, would that just be 2x minus 1 minus 5x? I think so. There's a I don't know option. In my college platform, you had to answer or else get it wrong or die. There's an I don't know option, but this is a knowledge check, which is not the same as a test, even though I literally took a test last time I was in this thing. It doesn't matter what the answer looks like, just as long as it's right. Well, I understand this to mean r minus s is just, you know, r minus s. So 2x minus 1 minus 5x. So 2x minus 5x, it's going to be negative 3x minus 1. Negative 3x minus 1. Yeah. Negative 3x minus 1. So I awkwardly reach around everything on my desk. Alright, r times s. So 2x minus 1 times 5x. That's going to be 10x squared. 10x squared minus 5x. And that doesn't really break down anymore. And then r plus s times 2. Oh, r plus s to the second. So I think what they're saying there is replace, so r plus s, but then the x is a 2. I think that's what that's supposed to mean. And in that case, it's 2 times 2, so 4 minus 1, which is 3. And then 5x, 5, 2, that's 10. So 3 plus 10 is 13. I think that's what we're looking for. I don't know. I hope. I know I didn't even write anything down there. Multiply. Okay, well, that's easy. That makes me kind of think I got the last one wrong. Reynard says yes, though. So hopefully we're onto something. All right, w plus 4 times w minus 4. W squared minus 4w plus 4w minus 16. W squared, those w's just sort of cancel each other out. Minus 16. W squared minus 16. Pretty sure that's how that works. 7 squared minus 1 w was square. Sorry, Reynard, I'm not sure what you're saying. All right, we're gonna submit. Find the least common multiple of those. Least common multiple. All right, what do we have in common? Well, 15 and 12 have 3 in common. And yeah. All right, so 3c squared is the least common multiple. That's got to be it. Okay. 3c squared. I'm just gonna bust through some of these, hopefully. I'm not gonna bust through that very quickly. All right. So we got a big old thing on a big old thing on a big old thing on a big old thing. Luckily, I'm pretty sure I can rewrite this and do some multiplication. So we have 15 n cubed over 7 x to the 5th y to the 4th. Now I could do my thing there, but instead I'm going to do this right here. You'll see in a moment why. 5mn squared over 28 x cubed y. Okay, so the reason for this is because with division, you can just sort of like cross multiply or something. Or am I thinking of equals? Crap, what am I thinking of? Anyway. Yeah, so all that divided by all that. If it was multiplier, we could go straight across. But it's divide. So I think we can do the x. Buffalo albino. The least they could do is tell you if you got it right or wrong. That way you know how much you have to cheat to pass. Yeah, seriously. I agree though. Like, at least tell me if I got it right or wrong. That would be nice. Because I don't even know right now. I don't even know. So, okay, well let's do our cross multiply. And so I think this one comes up to here. All right, cross multiply the factors and then simplify by subtracting the exponent on each variable. I think that's what we're going for. So with the how we're doing this one's gonna wind up coming up here. That's gonna go down there. I think that's the right way to do it. I think if it was an equal sign here, we'd cross multiply, except this would come up here. And anyway, I'm getting maybe a little oh yeah, the equals one is definitely different. Then you have it on either side. Okay. So 15 times 28. This is gonna be a big number. So 300. What's 15 times 8? 80 plus 40, 120. So 420. Oh, okay, that's funny. So 420 x to the third, y, n to the third. I know that's not alphabetically in order. Whatever. All right, then bring this down here. 35 x to the fifth, y to the fourth, m, n squared. Okay, and then we get to get rid of some things here. So 420 divided by 35. I don't know if that divides cleanly. Apparently it does. I just checked my calculator. That comes pretty cleanly to 12. And then the x's, this top x is going to go away. Got an x squared on the bottom. Top y is going to go away. Y to the third on the bottom. M only exists on the bottom. It's going to stay there. Bottom n goes away. And we just get an n on top. Pretty sure that is how that works. So we did end up with something smaller in the end. So I think the division worked. Yeah. All right, let's type this out here. 12n divided by x squared y the third m. I think that's it. If not, I won't know anyway. All right, factor. I don't like factoring because it just feels like a guessing game when I do it. Okay. 24v squared x to the third y to the sixth minus 18 v9 x8. Reynard agrees with my last problem here. Good. Okay. So we can factor both of these out. How does it want me to factor? So let's find some stuff in common. So 24 and 18, they have 6 in common. I think that's the biggest thing in common. So we're gonna pull 6 out. 6v squared x to the third. I think that's all I can pull out here. That's one of them. And then what remains here? I think I'm doing this wrong. But yeah, I'm kind of doing it wrong. But I think I can save it. 6v2x3. Yeah. I'm finished my 4-page of math. Good job, Jacob Castro. Okay. Okay, and then so this has to apply to both, but you know, we're just gonna continue on here. So 6 times 4 gets us to that 24. The v and the x aren't already there, so y to the 6th, and then minus whatever this is over here. So 3. Is it v to the 7? Yes, because it's not an exponent. It's a multiplication. Yeah. So v to the 7th, x to the 5th. Okay, I think that's how that factors out. That times those ones is the factoring. Math. Okay. This is going to be a long answer. Sixth There's 3v to the 7th. Nope, that's a b, not a v. And then x to the 5th. I think that's right. Is the answer asking for the factor or the whole equation? Well, it says factor the following expression, so I think it's asking for the factor. I think that's what it's asking for. So it factors into that. I think that's the most we can break that down. Yeah. And then if you multiplied that back in, you would get that up there. So I think that's right. If not, we won't know. The function g is defined as that. Find g of 5x. Interesting. G of x is that. So g of 5x. Wait. What does that mean? If it was g of 5... Okay, I think I get it. So if it was g of 5, x would just straight up be replaced by 5. G of 5x, we replace the x with 5x. So in other words, that 3 up there is going to turn into a 15. So, so g of 5x is equal to 3x squared plus 4. But yeah, then let's do this whole like 5x thing. So I'm pretty sure we get 15x squared. And then still plus 4. Is that it? Is that it? For some reason I thought that would take more to solve. Why is this yellow? Why is it highlighting that? Oh, Reynard says 25. Now why would this be 25? So yeah, if it was just g of 5, stick the 5 in place of x, that's 25 times 3, 75, plus 4, 79. But that's not what it's asking for. 25x squared. Oh, is it? Because the squared applies to both. You are smart. I'm glad I have you. Here, let me rewrite this, because I think I missed it because I didn't write it right. 3, 5x squared plus 4. Okay, so the squared is going to apply to the 5 and the x. So 25x squared. And then 3 comes in, 75x squared plus 4. That sounds more right. Okay, yeah, that makes more sense. So let's do that. 75x squared plus 4. I think that's it. I think that's better. What do you think, Reynard? You've been very helpful. Yes, awesome. Have the Reynard approval. Yeah, I'll submit that. We're halfway. I guess you can't quite see. Here, let me. All right, yeah, there you go. We can see up here halfway. In fact, this is a big question. Oops. I'm just gonna go full screen here. Okay. The Sugar Sweet Company is going to transport its sugar to market. It will cost a lot of money to rent trucks, and it will cost an additional lot of money for each ton of sugar transported. Let C represent total cost in dollars, and let S represent the amount of sugar in tons transported. Write an equation relating C to S, and then graph your equation using the axes. Using the axes below. Don't you mean axis below? All right, everybody, we're going to graph our equation with an axe. Hold on. I'm graphing an axe. That's kind of an axe right there, right? Okay. Big questions deserve big answers. Big questions don't deserve nothing. Alright, so we're gonna graph with the axes below. Alright, so let's actually figure out an equation here. So what do we have? So it will cost 7,250 to rent trucks. So that is a constant amount. And $250 for each ton of sugar transported. So that sounds like 250x plus 7250. So C represent the total cost in dollars. S is the amount of sugar transported. Albino Buffalo, you're in luck, Joe. I just so happen to be carrying an axe with me. Oh, good. Maybe we can answer the question with it. Although if you only have one, that's not enough. We need axes, plural. Okay, so C is the total cost. S is represents the amount of sugar transported. So C, which is the total cost, and S is the amount transported. So 250 for each ton transported. So 250s plus 7250. I realize I'm not showing what I'm writing. Maybe I should. All right, we're gonna split this a little bit here. So I realize it's cutting off some of the problem, but whatever. So I'm pretty sure this is what we're looking for. So the cost is equal to 250 S. S is for each ton of sugar, so 250 per ton of sugar, plus that initial cost of those trucks of 72.50. C is Y and S is X. Yeah, pretty much. So, you're in luck, Joe. I have axes, plural, out in the well house. In the well house, where do you live, Albino Buffalo? Live on a farm? Because that's pretty cool if you do, actually. Okay, so rise over run. Here's the thing. Rise over run is usually like x over 1, right? So 4x, it would be 4 over 1. There's no way this is 250 over 1, because that'd be a rise of 250. Oh, wait, no, that totally works here, because there's 1. Okay. So with 1, so S is 1. So we just got to math that out. So 7,500 is going to be right. Uh-oh. We can't do 7,500. All right, then we'll have to just skip up to 2. That's going to be 5. No, skipped 3. 750. 8,000. And then I guess we'll go to 7. This equals 250s plus 7250. Yeah, that's what I got here. It's a line. Yeah. As a matter of fact, Joe, I do live on a farm. Oh, that's so cool. It starts from 7250 and increases 250 for every units in X. Yeah, I get that. It's kind of awkward because the graph doesn't have I can't put a point at 7250. So, plot a point. What's that? Yeah, I'm just gonna forget about that. Okay. No, we want the pencil. Okay, so I think 7 is gonna be our next one. So 1,000 plus 750, 9,000. So at 7, it's gonna be 9,000. We can make a line there, and that starts at what looks like 7250. So I do believe that works. Now we have to do an equation as well. So C equals 250 S, capital S, yes, plus 7250, and yeah, I think that's it. We'll submit that. The entire graph of the function h is shown in the figure below. Write the domain and range of h using interval notation. So the domain... I think they're trying to throw me off with the curve here because... Oh, no, they're not, because we have an open circle and a closed circle. Okay. So... Okay, so this is not infinity. Infinity is not going to show up anywhere here. We have union. Interesting. We have union, but we don't have and, or whatever that version of that is. Okay. Interesting. So domain is going to be here to here. Oh, I just noticed the brackets and all that. Okay, I feel like I got this. So -5, comma 4 bracket. Bracket is because it's a closed circle. That is kind of like greater than -5, but less than or equal to 4. So I think I got this. Okay, and then the range. I guess I gotta start from the low one, huh? So the range is gonna be -3. And that's gonna go all the way up to 5. So I think that's what we're looking at for that one. This one threw me for a loop for a moment, that's for sure. Yeah. I think, oh, excuse me. Yeah, I think that's it. There'd be a union, I think, if it was like 2 graphs or something, but it's not. So let's move on here. Factor completely. I don't want to factor completely. Go away. Okay, well, we need to flip. Excuse me. Okay. We got 10x to the 4th minus 32 x to the 3rd plus 6x squared. Okay, so first thing I noticed is that we have some like major high x's here. So I think x squared is going to pop out here. Factoring's hard sometimes, you know? So how are we going to factor this one? So usually the end will give me a hint. Like if it's 6, then it's either 2 and 3 or 1 and 6 on these end numbers. But I'm not so sure right now. This x squared might not just be x squared. It might be like 5 or something. Okay, but with this 6 here, we can either do 2 and 3, or we can do 1 and 6. I'm thinking 1... If we do 1 and 6... Here, I'll just write them out here. 3x, 2x. 3x and 2x are what you're thinking, huh? Maybe. Then we gotta figure out the beginning. This is why I don't like factoring. Can you factor partially, or how about factoring incompletely? If it works, we could do like a one-sided thing, but I can tell this one's gonna do like an even kind of thing, like 2 things here, 2 things there. So if we did 1 and 6, then to get this 32, that needs to add up to that. And then we have the 10 here. So that's either 2 and 5. So the 2 and the 5. Okay. Here, let's get rid of that for a moment. So let's forget about x's for a minute here. So I'm thinking 1 and 6. 5 and 2. Because this 5 will give us, it's going to be negative and negative. Okay. This 5 will give us negative 30, and this will give us negative 2. So if I make this squared and these are just x's, I think that'll work. 1x, yeah, I know it's ugly. 1x, that makes sense for that. And then okay, I'm pretty sure that's it. I'm pretty sure that is the factor of that situation. To check it, we can multiply it back out. So 5x squared, all that. So 10x to the 4th, and then minus 30x to the 3rd, minus 2x to the 3rd, plus 6x squared. And I already know it breaks down into that. So we factored it. Awesome. 5x squared minus x 2x squared minus 6x. Okay. Make sure I wrote that down correctly. Yeah, I think we got it. So submit that. Simplify. Awesome. Okay, so this one, negative 3x to the 4th, y to the negative 2, and all that is going to get an exponent of 3. When it's written like this, it multiplies those exponents. So now this is going to apply to like everything in here. So this negative 3 is going to be a negative 27, x to the 12, y to the negative 6. Now, y to the negative 6, we got to move that. So negative 27x to the 12 over, technically it'd be 1 over y to the 6, but like we don't write the 1. So y to the 6th gets bumped down there. Simple. Simple, simple. Negative 27x to the 12th over y to the 6th. Feel good about that. Yep. Okay. Submit that. Question 14. We're almost through. I mean, like, we got 6 left. I guess we're like a third of the way through, but find all real zeros of the function. If there is more than one answer, separate them with commas. This is gonna have some factoring. Okay. Alright, so we got h of x equals 2. I always write it out first, especially if it's a big one, because if I don't, I'm probably going to forget part of the equation. X plus 7, and that is squared. X minus 7. Okay. So this breaks down several ways. So I'm pretty sure we break this down as x, yeah, x plus 6, x minus 6, x plus 7, x plus 7, x minus 7. Yeah, look at that beast right there. Now, find all real zeros of the function. What matters here is what's inside these parentheses. Excuse me. Yeah. Reynard, I just came out of work and now I'm doing Joe Man's math homework. This is my life now. Yep. I'm glad I can share. Okay. So what matters is what's inside the parentheses here. So what do we have here? we have x plus 6, minus 6, plus 7, another plus 7, don't worry about it, and minus 7. Pretty sure. Yeah, so what we do is we set these all like equal 0. So really, we're going to get negative 6, positive 6, negative 7, positive 7. And then don't worry about this 2 times over here. Yeah, just don't worry about it. All right, so find all real zeros of the function. So we're definitely going to be using some commas here. So negative, I'm going to put them in ascending order. Negative 7, negative 6, 6, 7. Now, I could plug this in place of x, but like that doesn't really get me anywhere, so I'm not going to. Because what is it equal to? H of x. Okay, that means nothing. So, I think that's it. Yeah, so you set all those equal to 0, and then that basically just sort of flips them across the thingy. I'm going to submit that. 3/4 of the way done. Plot 5 points on the parabola. The vertex, 2 points on the left, 2 points on the right, and click graph function. Okay, for this one, I remember we need to do x, 1, 2, and blah, blah, blah. So, negative 2, negative 1, 0, 1, 2. And because it's parabola, honestly, we only need to figure out 3 of these ones out. Getting off the page, or getting off camera a little bit here. So. All right, so if x is negative 2, what's y going to equal? So, a little bit of mental math here. Ooh, this is fun. Do I do x minus 3 and just swap the x for negative 2 and square all that? Or do I do x minus 3, x minus 3, and then swap it both times? I think the first thing I said is the right way to do it. Hopefully. All right, so I'm just gonna do some mental math here. So x minus 3, so negative 2 minus 3, negative 5 squared. 25 plus 2 is 27. That's I don't think that's right. 27 is not going to fit anywhere on here. All right. Negative. Well, okay. Let's do some mental math here. If we factored that, if we broke it into x minus 3, x minus 3, what does that come out to? Negative 2 minus 3 times negative 2 minus 3. That's negative 2 minus 3, which is negative 5, times negative 5. That's still 25 plus 2. That's still 25. That's still 27. So I guess y is 27. I don't know how we're going to graph this. Okay. And then we have negative 1. So that would be a 4, 16, 18. Oh dear. 0. 0 minus 3 squared, 9 plus 2. Oh boy. 9 plus 2. Yeah. 11. So, like, none of these are going to fit on the graph. I must be doing something wrong. Alright, and then... Okay, this is where things get interesting. Because... then 1 here. 1 minus 3 is going to be negative 2. Square that, you get 4. Plus 2, 6. 2 minus 3. Oh! I think... Yeah, we haven't even found our vertex yet. Because I figured it out. We need to keep going up. Because our vertex is not 0. Okay. See, I'm learning. Okay, so I'm just going to keep going. So 2. 1 squared is 1. Plus 2 is 3. 3 minus 3 is 0 plus 2. 2. I don't know how far I have to go with this. So stick a 4 in there. Okay, I think we found our vertex. So if we stick a 4 in there, 4 minus 3 is 1 squared. It's 3 again. Perfect. So this is our vertex right here. It's our vertex. And then everything branches off. So we just got to find the 5 here. Vertex is at 3. Thanks. I should have figured that out before because you just got to zero out the thing. Anyway, yeah, so 5 minus 3 is going to be 2. Squared is 4. Boom, 6. I could have also just worked up here. Like, this is probably 11. Probably 18 and 27. Okay. So, what matters is what's between here. Well, what's between here? That. Okay. Let's plot some points here. So. Okay. So, when x is 3, y will be 2. When x is 2, y will be 3. When x is, oops, yeah, it's kind of equals out. And then over here, we're going to be at there and there. Graph a function. Perfect. So I'm pretty sure that's what we're looking for here. And then if we're at 0, let's say it's probably about 11. Okay, I'll submit that. I feel good about that. Graph the solution to the following inequality on the number line. Okay, so we're going to have a couple things. So x plus 5 and x minus 7. We do our little mathy flippies with that. Really, it's x plus 5. We just take that alone. I can't highlight it, but we just take that little bit. So x is less than or equal to negative 5. Less than or equal to is going to be a solid dot, negative 5. And then we got a plus 7 over here. Less than or equal to plus 7. So really, this whole thing is just going to be like less than and less than, right? Yeah, because x never gets negative. So, I'm pretty sure that's right. Well, now I'm doubting a little bit. It's less than both of them, so really it's just less than 7. Like, yeah. There's math for you. You think you got it, but there's always a creeping suspicion. Okay, well, I think that's it. So I'm gonna submit here. Hopefully that was right. Write the following expression in simplified radical form. That is some craziness right there. Okay, let's write this out here. Okay, so we have a 5th root. That's pretty crazy. Ankry, I've completed my OpenGL renderer work for the evening. Good night, chat. Good night, Ankry. Good job with your OpenGL renderer. Okay, 90, 96. We're going to have to pull a lot out of that one. Y to the 6th. Z to the 15th. Okay. I already know Z to the 3rd is going to get pulled out, but I'm going to wait a minute on that. I'm going to pull some stuff out of 96. So this is probably going to be a cascade of 2s, but okay, so we pull 2 and 48. Pull 2 and 24. We pull 2 and 12. We pull 2 and 6. We pull 2 and 3. Hey, convenient. There are 5 2s right there. So, this is going to come out to 2. Oh yeah, and this y, we pull 5 out, and anyway, so that's just a y with no exponent. Z to the 3rd. That's going to be to the 5th root. And this 3 just got left behind. And the y kind of got left in there. The z escaped, though. So there's that. Now let's actually write it down. So 2y to the 3rd. Then we got to do a 5th root here. 5th root, 3y. 3y did not escape. Everything else did, though. Submit, because I feel good about that one. All right, graph the thingamajiggy. Cool. This is going to be a V shape. Aha. All right, I'm not ending the stream, but this song came up. I love how your notebook says true gaming at the bottom, and up there, there's only math. Can't get any more gamer than that. Yeah. It's an MSI notebook. Came with a laptop I got a few years ago. just happened to be the notebook that I had. Okay. So I'm going to do a similar thing as before. This one will be, it's going to be similar to a parabola, but instead of like a loop, it's going to be straight up V shape. So let's do some X's and some Y's and see where we go from here. So I want to find the vertex. I'm pretty sure it's going to be at 4. So I'm just going to start there. So x4. So 4 minus 4, 0. 2 times 0, 0. Plus 2, 2. I'm pretty sure that is the right place. Then we throw a 5 in there. 5 minus 4, 1. Times 2, 2. Plus 2, 4. Throw a 6 in there. 6 minus 4 leaves 2. 2 times 2 is 4. Plus 2 is 6. Okay. And then I realize this is a little out of order, but 3 going the other way. 3 minus 4 is going to be negative 1, but you know, the whole absolute value thing, it's 1 times 2 is 2 plus 2 is 4. So yeah, I think we know what we're doing here. So let us put some dots down here. Let's see. So our vertex was at 4, and it's going to be right there. And then at x5 we have 4, x6 we have 6, and then going back x3 we have 4, and I'm just going to take a wild guess that at x2 we also have 6. Oh. So I guess we're gonna put some rays down. That's not right. Hold on. It's weird because it doesn't have graph a function. It's just rays. But I'm pretty sure that's right. I'm pretty sure this is the right way to graph it. Yeah. It's not a line because it's infinite. Line would indicate some sort of end. Plot a point. I don't know how that works or what it is, but I don't think that's it. So I'm going to submit this. Ray just goes on forever. All right, question 19. We're almost done with this. We might just have some time at the end to actually study some math. For her phone service, Karen pays a monthly fee of $13. Cheap phone service. Good job, Karen. Find them deals. And she pays an additional 6 cents per minute of use. The least she has been charged a month is $85.18. What are the possible numbers of minutes she has used her phone in a month? All right, well, I'm going to make this full screen so you actually... Oops. Other full screen so you can see the whole problem here. Okay, so she has been charged... So the least she has been charged in a month is $85.18. So whatever we're doing here is greater than or equal to $85.18. At least she's been charged. She could be charged that low again. But yeah. So 13. Monthly fee of 13 and 6 cents per minute of use. So x 0.06 plus 13 equals is less than, no, is greater than or equal to 85.18. What are the possible numbers of minutes she's used her phone in a month? Use m for the number of minutes. Solve your inequality for m. Okay. But if she speaks to the manager, she pays 50% off. Oh, is that what's going on here? Okay. Well, I'm going to switch back to the split screen here. I got a new piece of paper. Okay. So whatever we're doing here is going to be greater than or equal to 85.18. And what are we doing here? I think we got 0.06, make a better period, 0.06 m plus 13. So yeah, if she talks 0 minutes, it's just 13. But this would not be valid because it's not greater than or equal to 85. So we have to find out how many minutes. Yeah, we got to solve for m right here. So first easy thing is move 13 over. So 0.06 m greater than or equal to, let's see, it's minus 13 from that. So it's going to be kind of a bad 7. Sorry about that. It's going to be 72.18. And then we got to just sort of multiply that by 0.06. That's a little much for my mind to do. So 72.18 times 0.06. No, not times. Let's try this again. 72.18 divided by 0.06. 1203 on the dot. So m is greater than or equal to 1203. Now, what are the possible numbers of minutes she has used her phone in a month? At least that many. She's never used fewer minutes than that. And, you know, while we're here, 1200 divided by 60, that's 20 hours of talking in a month. That is so much talking. Oh, boy. Okay. So, yeah. The minutes she's used is greater than or equal to 1,203 minutes. So let's put that in here. Greater than or equal to 1,203 minutes. It can be as low as 1,203, but it's probably greater than. It can be equal to, but it's probably greater than. Yeah. Pretty sure that's it, so I'm going to submit. It's always just a little nerve-wracking. Because I don't even know if I answered right, you know? The sets A and B are given below, and this is the last question, by the way, of the knowledge check. The sets A and B are given below. A is those things, B is those things. Intersection and union. Now, I gotta remember the difference between intersection and union. The camera shakes when I do that. It's kind of funny. Okay. The way I remember is intersection. It's got that, and union has that, right? So union. No, so intersection is that, which looks like an N, which is and. So if it's in one set and the other set, you get it. Union is just sort of the leftover losers. I think that's how it is. Jacob Castro, done 6 page. Good job, Jacob. Okay, so for the and here, whatever appears in both, which is H. Literally only H. Hold on. I think I gotta do braces. I think so. All right, and then the union. Union is gonna be pretty much everything else. So I'm gonna go alphabetical here. Let me get some braces. So we got A, D, E, J, and then H. H was up here. Huh. No, I think H also appears down here. Because okay. Here's how it works. So this one, which is intersection, in computer logic, this is and. It's this and that. If it appears in both, like H does, it's and. This U right here, union, is or. It can appear in one or the other. But if it appears in both, it's still fine. It's not exclusive or, it's or. So H appears there, I think. Submit that. Yo, mastered 41 topics! You need to revisit one topic. Uh-oh. Let's go full screen here. Yeah, so real numbers, still doing great there. It's filled out. The blues look better than before. I don't know what we were at before this. Can I go back to the beginning of my stream and actually just look? Hold on, I'm gonna... Somewhere in here. I was at 172 before. It says I mastered 41 topics, but I was at 172. Not to boast or anything, but I know a thing or two about math. This is not 41 larger than 172. Anyway, yeah, let's continue my path. Actually, let's go back to the main menu. Back to home. All right, 22 minutes left in learning module. I don't know if I have to like finish this, like fill that up before I do my test tomorrow, but I want to make sure. It'd be awkward if I got there and it's like, hey, you got to do more studying. No, I don't want to do that. Sorry, I'm getting a little far away from my microphone. Okay. Yeah, let's continue my path here. Although, I wanted to learn about logarithms and tangent, and secant, and cosine, all that good stuff. All right, whatever. I'll do a little bit here. So, going to there it is. Go split screen here. Okay, so solve for x. Okay, well this is easy. It's absolute value, and I swear I did this in my little knowledge check that I just did. Yeah, so basically, you know, whatever. We'll talk through how it says. So we have if thingy and thingy, thingy, thingy. So if b is less than 0, so if this thing over here is less than 0, it's going to be no solution. Yeah, because an absolute value can't be less than 0. So that already tells us from the get-go. So 6x blah 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 equals 12. 12 is greater than 0. So there's a chance, at least. And then b is greater than 0. Yep, okay. So then we have to solve it with 12 or negative 12. And so then we go through and get our x, and then we could plug this x back in and actually check it. So, all right, Reynard, have a good night. Thanks for helping me on the knowledge check. Okay, so absolute value of 4x plus 12 equals 4. So we're going to break that into negative 4 and 4. 4x, we're going to minus 12 from that. Negative 16. X equals negative 4. And then 4x over here, and minus 12 from that. That's going to be a negative 8. So negative 2. Negative 2 and 4. We can plug that back in to find out and make sure. And I'm going to do that because I don't trust my math all the time. So negative 2. So 4 times negative 2, that's negative 8. Negative 8 plus 12 is going to be 4. Absolute value of that, 4. 4 equals 4. Yes. Negative 4. That's going to be a negative 16. Yeah, that checks out too. So awesome. Let's do that. So negative 2, comma, negative 4. Awesome. Oh, this is the thinking song. This right here is the thinker. All right, 5u plus 15. Oh, hold the phone. Hold the phone. Hold this. Hold the phone. It's a negative 5. It can't possibly equal negative 5. Also, that was far more violent than I expected it to be. Just trying to get my phone out here. That's a negative 5. It can't possibly equal negative 5, so there's going to be no solution. Having memories, welcome to the stream. Yeah, we're just having some fun with math. Yeah, no solution on this one. Keep it up. Awesome. Okay. Graphing a cubic function. A cubic function of the form y equals ax cubed. Okay. So this is just a steeper parabola, right? Plot 5 points. Yeah, so you just throw some things in place of x. So x those, you do your math, and then it comes out to those numbers, right? Okay. Oh, it's not a steeper parabola because a squared would turn negatives into positives, because because like -3 times -3 equals +9. This is a cube, and cubes don't do that, because like -3 times -3 times -3, yeah, that'd be -27. So there's that. So we get this little like, you know, little bump in a line basically, instead of a parabola. I'm gonna put my phone back. Okay. That's cool. All right, let's start this one up. So we have a pretty easy one here. So we're gonna do the same thing as we normally do. Get our X's and Y's. This is not plus anything. So the vertex, well, it's not a vertex on this one. The start point should be at 0. So -2, -1, 0, 1, 2. So if we pop in a -2 in place of X, -2, +4, -8. So -5/4 times 8. 5 times 8 is 40. So -40 over 4. No, hold on. It's +40, isn't it? Let me back up. I was doing too much in my head there. I'm gonna do it off to the side here. So -5/4, -2 cubed. That's gonna turn into -5/4 times -8. Okay, negative. That's gonna give us 40 over 4, which is 10. So y 10. There we go. Y 10. Okay. Fabio Vaca Arroyo Dacia. Hopefully I said your name right. You have a fancy name. Hey, boss. Hey, Fabio. Welcome to stream. Just doing some math here. Got the thinking music going. So, okay. So we figured out one of them. So that's just sort of mental math, this one. So -1. So we cube that up, and it's still -1. But it's going to make this 5 positive. So positive 5/4. And then 0. Hope this doesn't come as a surprise to anyone. That's 0. 10 times 10 is 10. What? Not Doge Halo. I don't think that is correct. I think you are wrong. All right, so 1. Give me a -5/4. And if we pop a 2 in there, that's going to be 8. It's going to be -40 over 4. It's going to be -10. Perfect. So we could still figure out 3 of them. And then as long as we get to the, you know, midpoint, the vertex, we just sort of negate the other ones. So let's pencil this up. So we're at X is -2, Y is 10. X is -1. We have 5/4, which is it's a little more than 1, but only a little bit. Plot 5 points on the graph of the function. 1 point with X equals 0, 2 points with negative X values, 2 points with positive X values. Then click on the graph of function button. All right, well, I'm gonna go close. I really hope it doesn't hate me for this. Oops, that was not right. All right, and then yeah, when X is 1, Y is -5/4, and then 2, we have -10. This makes me uneasy, because it's not exactly that. It's just close, you know? But I can't do like -3. That'd be way off the graph. Hey boss, why 2 + 2 = 4? Because reasons. That's why. Okay. I don't feel good about this one. Here, I'm gonna undo. I'm gonna try this whole plot a point thing. So, okay, so X. Yeah, let's try this again. So X is going to be -1. Y is going to be 5/4. Okay, that's better. And then we have 1 and negative 5/4. I feel a lot better about that. Okay. And then graph a function. This should be correct. Awesome. Okay. You know, I think we're going to get through this, and I might actually just, like, call it for this. I think I've done enough of this. I want to end on a high note because I feel like I'm doing good right now. So, yeah. So many lines. The first one didn't work out, so I just drew some more. Alright, so we have our X's and our Y's. We don't have any pluses, so I think you can still go with the standard set. So, if we plug a -2 into that, I will math out this first one. -7/8 x cubed. So, -7/8 times -2 cubed. -7/8 times -8. Well, that's convenient. Those are just sort of going to cancel out. And then we're going to have -7. Oh, wait, but there's a negative there, so it's actually +7. Perfect. Okay, and then 1, I'm just going to try and do this mentally here. So, -1, still a -1 when you cube it. That's just going to be 7/8. +7/8, of course. Then 0, yeah, it's going to be 0. No, that one. This should be -7/8 and -7. Okay, we can plot some of these points, but we're going to need some help. We're going to need to use the plot a point in a moment here. Okay, so we have an x of -1 and then 7/8. Boom. And then 1, -7, nope, not 7/2, 7/8, perfect. Okay, that should be it. Check. Awesome. All right. I want to see what the next thing is, but I don't think I'm going to do it unless it's really easy. Yeah, no. This means you factor it, and then you have your two things, then you cross out the things, then you have your thing, and then I don't want to do that. We're going to go back to our homepage. Okay. Dang it, I still got to do 10 minutes, though. Okay, we're not done yet. We're not done quite yet. Let's get back into it. So you do the thing, you factor it, and then you cross out your things, and then you have these things left. It really is that simple. There's y plus 1, y plus 1. Yeah, those go away. So, okay. Let's get a new sheet of paper. Flip this over. Okay, so we're going to go w squared minus 5w plus 6. Put all that over 5w squared minus 20. Jacob Castro, just an emoji of a pencil and paper. Yeah, pretty much. Okay, so let's try factoring this out. So the top one, I think it's pretty easy. Let's give ourselves some space here. It's going to be 1 and 6, and they're both going to be... Wait a second here. Going to have a positive and a negative? No. If it's a negative and a negative... If it's a negative and a negative, they'll multiply to be this plus 6. So minus 1 and minus 6, you get plus 6 when we multiply. Minus 1 and minus 6, that should be a 7 though, if that were the case. So this is 2 and 3, not 1 and 6. So negative 2, negative 3. I don't think the order matters. Okay, So that breaks into that. And then factor this other one. This looks fun. So 5. So if I did 5 times w squared minus 4. No, I'm going to write it over here. I think what we're going for is 5 times w minus 2 squared. I think that's what we're going for, actually. Because then the squared hops in there. No, that's not it either. Maybe it's 5w minus 2, w plus 2. And then if we do that, well, if we multiply it back up, we get w squared. Hold on. W squared. And then we'll get plus 2w minus 2w. They'll cancel out. Minus 4. 5w squared. Those cancel. Minus 20. Okay, so that does work. 5w minus 2, w plus 2. So those ones are going to cancel out, and we're pretty much left with the rest. The rest being w minus 3 over 5w plus 2. And that is that. I'm pretty sure. So, w minus 3, all that over 5w plus 2. Let me double check. Yeah, looks good. Alright, we'll check that. And it is correct. Awesome. This one looks even more fun. I say that sarcastically. Maybe 5w squared minus 4. I thought about that, but no, not quite. 5. Because then that 4. Well, I guess technically that would work. Technically, the 5w squared minus 4 would work. It's just that that can factor out more, so it's not factored out enough. It's not wrong. It's just not factored enough. Okay. So u squared plus 5u minus 24 all over 3u squared plus 9u minus 120. Okay, so let's see if we can factor this one out. So the top one, I'm pretty sure is 3 and 8. It's going to be plus 8 and minus 3. And then the bottom one, music just skipped a little bit there. The bottom one is going to be like 3 times something. Alright, 3 times. So if we divide all these by 3, that's going to be u squared plus 3u minus 40. Okay, so a lot of things going to 40. We have 4 and 10, 5 and 8. I think 5 and 8 are the ones we're going to use here. U plus 8 and u minus 5. Okay, and then those cancel out. So then we just got to rewrite the finished product. U minus 3 over 3 times u minus 5. Awesome. feel like I'm in a good flow right now. U minus 3, all that over 3u minus 5. Check. Mate. Awesome, we got it. All right, one more. One more here. So, w squared plus 4w minus 5 over 4w squared minus 4. It's going to be a similar situation to up here, I think. Okay, so again, the top is going to be the easier one here. All right, so for this negative 5, it's going to be, what is it going to be? Multiply to get to negative 5. We're going to have plus 5 and negative 1. So minus 1 and plus 5. And that accounts for the rest of that. And then over here, let's see, I'm going to have to... I think I'm going to have to break this one apart a little bit. So 4... I'm not sure if this 4 comes out or if it's going to be a 2 squared. I don't know, man. So w... minus 4? No, minus... It's kind of the same route I went up here. Yeah, very, very similar to up here, actually. Okay, so I oh, no, it's not quite that. I think we're just working with ones here. Okay, so to verify this, I want to verify w squared plus w minus w. They cancel each other out. Minus 1. 4w squared minus 4, which is what we have up there. Okay, so this right here is the factoring of that. So 4w minus 1, conveniently, it matches what we have up there. W plus 1. Awesome. They cancel. W plus 5 over 4 times w plus 1. Awesome. You know, if I go too quickly here, it's going to make me keep doing more and more math, I think. Because I have to do math for a certain amount of time. Ain't that funny? All that over 4w plus 1. All right. Have I done enough? Ah, I have. Yeah, so, yeah. Hey man, just for curiosity, can you tell us why any number to the power of 0 equals 1? That is a good question. I know there's a video on YouTube about it. I have not watched the video. I've only seen the thumbnail for it. That's a good question. Let's see, if we explore that a little bit. Let's see, so 2 squared is 4, because the squared is like there's 2 sets of it. So 2, and then another 2. 2 times 2 equals 4. If it's to the 1 power, there's only 1 set. If it's to the 0 power, there are 0 sets of 2. Which would imply that it's empty, that there's nothing. If it's to the negative 1 power, then it is 1 over 2, which is 1/2. Yeah. Yeah, I don't know. I do not know. So, okay. I think I've done everything that I want to do in here tonight. What happens if I click in here? Oh, it just gives me information. Well, that's cool, I guess. Okay, so before we finish here, I want to I guess, practice a little bit with some sine, cosine, tangent. It's already 9 o'clock, though. I will be taking a test in the morning. I do need to get some good sleep. So, well, here, we did our knowledge check earlier. What did we learn from our knowledge check? I'm looking through my book right now. Oh yeah, we found some things earlier. I'm kind of like making the game plan right now. Like, I could keep streaming, right? Okay, so at the beginning, I wrote down. Switch over here. I wrote down sine, cosine, tangent, logarithms, and factoring. I think we got some practice with factoring on here. Got some good factoring practice, so I'll say that's good enough. Logarithms. Okay, yeah, logarithms, I feel like I could use a little bit of practice with. So, okay. So here's what I do know about logarithms. So if we have log 2, 8, I do know what this is saying is 2 to the what power is 8. 2 to the third power is 8. I know that much. What I don't know is if we have like 5 log 2, if that's even a thing. Oh, I also know that log 100, if there's just nothing here, it implies that there's a 10. So 10 to the what power equals 100? 2. I know that. What else do I know? I think that's pretty much it as far as logarithms go. Like, that's all I know. And then for sine, cosine, tangent, let's see. We have let's see, cosine is adjacent over hypotenuse. SOHCAHTOA. Jude Barrett. I made it! Welcome, Jude. Welcome to the stream. I already did a bunch of math, like 2 hours worth. I finally made it to a math stream. Yeah, good job, Jude. Right now, tomorrow morning I have a test. And I'm hoping I can do well enough to place up into a high enough math class. That said, I'm trying to kind of figure out where I am and learn some last minute things that I'm not learning from the Alex program on that pi over there. Maybe I'll learn it later, but I have not learned it yet. So I want to learn more about logarithms. And then we have SOHCAHTOA, which is sine opposite. How do I even spell hypotenuse? Hypotenuse. Yeah. Cosine. Tangent. I'm not going to write the whole thing. But, so, what I do know is, let's say we have a triangle here, a right triangle, and let's say this is 30 degrees. Opposite over hypotenuse. Okay. And then let's say that we know that this is 8. Basically, we can figure out this whole triangle based on just that information. Hey, Joeman 542 plus Joeman 1. What college do you do? Depends what you mean. I'm not going to say what college I go to, but I'm preparing for pre-calculus. I want to test high enough to get into a pre-calculus class. That's That's the goal. And the major I'm working towards is computer science. So that's fun. Okay, so if we wanted to figure out some stuff here, so we do need a calculator figuring out sine. So what we have here is sine is the sine of 30 equals the opposite, which is 8 in this case, over hypotenuse. So by doing this, we can figure out how much that hypotenuse is. So first thing we gotta do is multiply everything here by h. So h sine 30 equals 8. So we need to know what sine 30 is. So 30 sine, that's 0.5. So 0.5 h equals 8, which means, so we gotta multiply by 2, so h is 1. H equals 16. Awesome. So we now know 16 right there. So we're figuring out this triangle all on our own. Okay, so that's an example of sine. Now cosine is adjacent over hypotenuse. So we can use that to figure out this adjacent side, or we could use the Pythagorean theorem. I would probably use Pythagorean because I'm more familiar with that, but let's try using the cosine. So, gonna bring this on here. So cosine. So cosine of 30 degrees. So adjacent is unknown. Adjacent over hypotenuse. We know the hypotenuse is 16. We just figured that out. And so what we need to do is multiply everything here by 16. So 16 cosine 30 is going to be whatever the adjacent side is. So cosine 30, what we'll start with, which is some weird number. Multiply that by 16, which is kind of a weird number, but less weird. So 13.856 is the adjacent. We'll see, say 13.86. We'll do some rounding there. Gamerbread, welcome to the stream. Wart. Turns out the armed and dangerous goose at my door was British. Uh-oh, they might conquer your whole house. You know, expand the kingdom, expand the empire. Okay, so we now know all the sides of this, but we want to know the angles. Now, I just happen to know that 180 degrees is the total of all the angles. So 30, 90, well, this has got to be 60. But how could we use SOHCAHTOA to figure this out? Or let's say we didn't know this was 30. Yeah, that'd be interesting. Could we figure out the angle? Man, this is powerful. You can figure out anything about a right triangle. If it's not a right triangle, that's when it gets crazy. Did he throw it into the Boston Harbor? Oh, hold on. Did he stab you? No, he offered me tea. Did he throw it into the Boston Harbor? America! Okay, I honestly feel like I understand sine, cosine, tangent fairly well, actually. I know there's more that I could know, but logarithms, I feel like I could know a little bit more about logarithms. So I am going to call the stream here. I think I've done enough. I don't want to hurt my brain too much. So yeah, let me fix my camera. Let's see. There we go. And I am nice and upside down. And I'm still upside down. All right. Let me fix this real quick. And whoop, right side up. Perfect. Is this? It's backwards. There we go. Oh yeah. Cool. I think it's time to end the math for tonight. That's the wrong song. I always grab this wrong one. There's two of them. Okay. Well, I think it's time to end the stream. We did math. We did math. I feel good about the test. I'm allowed scratch paper. I'm not allowed a calculator. There will hopefully be a calculator on some of the questions in the test, especially if it asks for sine and cosine. But I know I'm not allowed a calculator. In fact, let me check. I can read exactly what's allowed. All right, let's see. So I need photo ID. Calculators are not allowed, but scratch paper will be provided. So I can't even bring my own scratch paper. I mean, it's not like I need different paper than they provide, but yeah. So they'll provide paper. And I can bring my pencil. I've been writing this all with a pen just so it's easier to see on camera. But anyway, I'm getting off tangent a little bit. Haha! Tangent! Okay. It's time to end the stream. So I'm Joanne543. Hopefully this is the last Wednesday math stream. I mean, they're fun and all, but the reason for them is for me getting better at math and achieving a certain point. So I want to achieve that. Anyway, I'm Joeman543. I'm going to end the stream here. I hope to see y'all on Friday at 7 p.m. when I do my actual, fun stream. And until then, peace. Bye, everyone.